will begin the lesson on the law of reflection with an experiment. You will need a flashlight and a fog machine. We will be using a humidifier. Students will shine their flashlight toward the wall or ceiling. What light do you see? Students will see light from the flashlight and light on the wall. Can you see light traveling? Students now hold their flashlight below the mist. What is the mist doing? The mist acts as a reflector. You can only see light when it reflects off an object or when your eye intercepts light emitted by a source. You can see light on the wall because it reflects off the wall surface to your eyes. All objects that are seen because light reflects off them are called illuminated objects, like the wall or the mist. Objects that give off their own light are called luminous, like the flashlight or the sun. Light always takes the path required least time. The shortest path between 2 points is a straight line. In this experiment, students will understand why light is essential to see. You will need a box and an image taped on one end. Secure the image on one end of the box and a hole on the other end so that students will be able to look through to see the image. The hole needs to be no bigger than a pencil. Secure the box and allow no light to see through and that students cannot see the image. Allow students to peek through the small hole and write down what they see without discussing. Once everyone is able to see, discuss how we might be able to see the image. Open the box lid only slightly to let the light in. How is light essential in our ability to see? And how is reflection essential in our ability to see? In our final experiment, we will need a mirror, humidifier, flashlight, or laser pointer. Caution: students should never look directly at laser or shine laser at any person's eyes. Turn light out and allow students to experiment with light and mirror. How does the angle of light change as you move your light source? How is the angle of source light compared to the angle of reflected light? We will next be testing our theories. The flashlight is also a very good way to see the reflection of the light if you do not have a laser pointer or do not feel comfortable using a laser pointer with students. Our last activity will test the theory of, does light reflect at the same angle of incidence? You will need a mirror, pencil, paper, tape, and protractor. I suggest performing this before class so you are comfortable and performing it with students their first time. Begin by securing the paper with tape. Place a dot in the upper right corner of the paper, about 4 inches down from the top edge of the paper. Hold the mirror along the top edge and position yourself at eye level with the desk and to the left of the dot. Close your left eye and draw a line from the open eye, which is your observation point, to the point where the dot is reflected in the mirror. Draw a line from that point to the actual dot. Where the two lines meet, use a protractor and ruler to draw a line perpendicular to the top edge of the paper. This is called the normal. Using your protractor, now measure the angle of incidence and reflection to see if they are equal. Using the normal as the starting point, measure left to the angle of incidence and right to the angle of reflection. This may need to be repeated a few times because there may be errors. Through our investigations, we were able to find that light is reflected from plane surfaces in a predictable way. Also, we were able to find the angle of incidence is equal to the angle of reflection, which we can now call the law of reflection. In further lessons, we will discuss diffuse